Hi guys, welcome to your Algebra 1 class. Today, what are we going to do is we discuss the continuation of solving inequalities. But today we'll be discussing in this video about solving compound inequalities. Remember the primary rule for working with linear inequalities. When you are multiplying or dividing by a negative number, it changes the direction of the inequality. So what is a compound inequality? From the term compound, it is two simple inequality joined by the word and the word or. Okay. It is also possible that your compound inequalities may contain, okay, an inequality and at the same time it contain an equation. So we know the difference already. Inequalities, they have inequality symbol while your equation has an equal sign. Example, if I have here x is less than 5 and, okay, there's the word and there, x is greater than -2, okay, or I can give you an example with the word or. So a plus 2 is greater than 4, or, okay, that's the word or there, a plus 3 is equal to 6. Now, what's the difference between the word and the word or? So for and, the equation to the compound inequality is a solution to both inequalities. Okay, it's to both of them. It must be solution to both inequalities. While your or, the solution to the compound inequality is a solution to at least, okay, at least one of the inequalities. Another difference is that the word and, both must be true, okay? And for the word or, either one, it's just only one inequality, or it can be both of them must be true, okay? Once there's an inequality that is true to either one or to both, then the inequality is an or inequality. The compound inequality graph is the intersection of the graph of the two inequalities, while your inequality using the word or, the compound inequality graph is the union, joining together of the graph of the two inequalities, okay? The intersection for and is where the separate answers overlap. And on the other one, they made use of, for the word or, it's the union. Union means it's the combination of all the answers. Okay. So as we go on with compound inequalities with all our example, you will we will discuss how and the word or difference the difference of and or using the graph. Right. So all of the script and transcript of this video is you can see it down below. All right, if you want to read them. Let's proceed with the first example that I have in here. So what are we going to do is how can you use inequalities to describe the set of numbers graph below? So as you can see, the graph is a solid circle on -3, while an open circle at +2. The graph shows the solution of two inequalities. The two inequalities form a compound inequalities. Okay. Again, a compound inequalities is made up of two or more inequalities. So what are we going to do is we have to write an inequality to represent the solution shown in each part of the graph. So on this graph here, okay, so on this graph, because again, we can distinguish if they made use of a greater than, less than, greater than or equal, or less than or equal, just barely looking at the graph. On here, because the point is a solid one, so they made use of a greater than or equal or less than or equal. But take a look at the direction of your arrow. It goes to the left, meaning every number, including the -3, is a solution of this inequality. Therefore, let's use x to represent those number. So the inequality here is x is less than or equal to -3. All right. While on the other side of the graph, we have an open circle. Therefore, they made use of a greater than or less than only. But take a look at the arrow. Your arrow points to the right. So the inequality here can be written as x is greater than +2. Make sure the your +2 here is not included. All right. So the compound inequality that describes the graph is x is less than or equal to -3, or, okay, x is greater than 2. Okay, so you see you see now the graph of the word or. All right, so that's how it looks like with the word or. Now, with the next example, so let's see with the next example. I hope this will be using the word and. Okay, so it uses the word and. In our next example, what are we going to do? It involves the word and. How can you use inequality to describe the set of number graphed below? Okay, so now when we look at the graph, there is a solid circle and there is an open circle. The solid circle is at -4, while an open circle is at +1. The solutions shown in the graph are greater than or equal to -4. They are also less than 1. So what are we going to do is to write the inequalities to represent these two inequalities. So if I'm going to graph that in a separate number line, so let us say this is -4, it's a closed circle, and then it goes to the right. While the other one is that an open circle on +1, open circle, and it goes to the left. So they join together. That's why we come up with this equation. Meaning, as you can see on the graph, there is already an overlap on both. So meaning, there are certain number in our equation in our inequalities that both of them are solution to these both inequalities. So the compound inequalities that describes the graph is we have x. Okay, for this one, we have the -4, that is x is greater than or equal to -4, while on the one, we have x is less than 1. 1 is not included in the solution for this part. Therefore, we can now write as a compound inequality. We can write that as -4 is less than, or -4 is greater than. Okay, so -4 is greater than, let's see, so negative, or x is greater than equal to -4, and okay, and x is less than 1. All right, so they made use of the word and. However, we can also rewrite this one as a compound inequalities, and it only applies for the word and. So what are we going to do on this part of the solution is that it only applies to your when you are using the word and in your inequality. You can put there -4, all right, is greater than x is 1. So we can read this one as x is greater than greater than negative 4 but less than positive 1. Okay? All right, next example is that we have this. Solve the compound inequality 5x minus 7 is less than 13 or negative 4x plus 3 is greater than 11. All right, so we have to solve each inequality. So in solving inequality, it's the same as solving equation. But remember, when you are dividing or multiplying with a negative number, you have to switch your inequality symbol. So first is we get your 5x minus 7, it's less than 13. And the other one is we have negative 4x plus 3 is greater than 11. So we have 5x minus 7, okay, and then we add 7 both sides, right? So we add 7 both sides on this case. So we add 7 both sides, I add 7, I add 7. So what will happen is we have 5x is less than 20. Of course, I'm going to divide both sides by 5. Therefore, this will be cancelled out. So x is less than 4. All right. So if I'm going to graph that, so you have 0, 1, 2, 3, 4. I'll be using an open circle. Okay. An open circle. And then it says they're less than. So all of the number less than 4 will be solution of this inequality. Right? And they made use of the word or. Okay, so or. So there's or in between them. Next is we have to solve this. So I'm going to subtract 3 both sides. Subtract 3 minus 3. Of course, this will be cancelled out. So what we will have is negative 4x is greater than 8. Greater than 8. Right, so I'm going to divide both sides by negative 4. Remember, we are now dividing with a negative number. So x is now equal to, or x is less than negative 2. All right, so if I'm going to graph that, so let us say that is 0, and then this is negative 1, negative 2, negative 3. So negative 2 is here. They made use of open circle. Negative 2, and it goes to the left also. All right, so if I'm going to combine this graph, this two graph in here, it will become like this. All right, so this is 0. Okay, that's 1, 2, 3, 4, negative 1, negative 2, negative 3. So if I'm going to graph positive 4, which is less than, it's here. It goes there. Okay. And another one is if I'm going to graph your 0 and negative 2, it will be here. And it goes there too. So both of them are in the same direction. So the solution is x is less than 4, which is the set of all real number less than 4. So as you can see, it included. So from here, 4 less than 4, it goes everything here, including the negative 2. Therefore, the solution is x is less than 4. Again, that is the set of all real number less than 4. Now, our next example is we have 7x plus 9 is greater than or equal to negative 12, but less than 16. So what are we going to do is, again, solve each inequality. So there are two inequalities there, and this inequality involves and. Even if you don't see the word and there, it's automatically, it involves and because of its form. Okay, so we're going to separate. It says there we have 7x is greater than or equal to negative 12. So we have negative 12 is greater than or equal to 7x plus 9. All right, 7x plus 9 is greater than negative 12. And we have 7x plus 9 is less than 16. So we have to solve this one. So we subtract 9 both sides because we are now combining like terms here. We subtract 9, of course, this will be canceled out. So we have negative 21. Negative 21 is, we have less than 7x. And then I'm going to divide this one by 21, or 7, sorry. So I have to divide that one by 7 because 7 is the coefficient of x. So therefore, we have negative 3 here that is less than or equal to x. Okay, so if I'm going to graph that, so we have 0 here, that's negative 1, negative 2, negative 3. Then if I'm going to graph that, it's negative 3, it's here, it's a solid one, and then pointed to the right. Okay, now on this part, we have to subtract 9 both sides, minus 9. So this will be canceled. So you have 7x is less than 16 minus 9 will be 7. And then I'm going to divide both sides by 7, right? So x is equal to, or x is less than 1. So that is 7. Sorry about that. So that's 7. So I'll just rewrite that. So this is 7. So x is less than 1. So if I'm going to graph this, all right, so x is 0, and this is 1 here. And I'm going to graph it's less than, it says there less than, so it's an open circle. And less than, all of the number less than 1, excluding 1, all right? So if I'm going to graph that in just one particular number line, okay, so I have here 0, and I only need 1 here, and then we have the negative 3. So of course there's a number in between there. So an open circle here. So it's an open circle and points there going to the left. And this one, negative 3, it's a closed circle. All right. And it points to the right. So you see it overlaps in there. So the solution here is all the number that is greater than negative 3, including the negative 3, but less than 1, excluding 1. So you can write this one as a compound inequality. It can be x is greater than or equal to negative 3, and x is less than 1. Or we can rewrite this one as a compound inequality that x is in the middle, but it's greater than or equal to negative 3, but less than positive 1. So this is now how you write the compound